I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on a Newton's second law problem. All right, so here we have a question where we have a 20 Newton force that is applied to a 5 kilogram mass. And we want to figure out the value of the acceleration if this is pulled on a frictionless surface. So here's what we're going to do first is we're going to draw our system schema. So we have the earth, the rope, and the surface all exerting forces on them. The earth is gravity, tension force by the rope, and a normal force from the surface. So now we're ready to draw our free body diagram. So we change the gravitational force to mg because we're on Earth, so we can calculate the gravitational force by doing mass times g. So we've drawn our free body diagram. Now we're ready to write our Newton's second law equation. And we're writing our Newton's second law equation for the x direction because that's the direction of acceleration. And we want to find the value of the acceleration of this object. So the tension force is the only force acting in the x direction. So I can see that because the tension force is the only force, that's the only force I have added to anything. So I set that equal to mass times acceleration. Then I solve for the acceleration, and I get that the acceleration is equal to the tension force divided by the mass. And then I can plug my numbers in, and I can see that the acceleration of this block with no friction is 4 meters per second squared. All right, so we're back here. Now we got a similar type problem. We got the same box with the same force being pulled at an angle, and you can see that there's friction as well. So what we're going to do now is we're going to modify our free body diagram and our system schema. Because we have a friction force, the box that's being pulled up and to the right is actually going to slide across the surface. So it's going to slide across the surface. So that means friction is going to oppose that motion by pointing back to the left. Friction that is supplied by a surface is always going to be drawn on the horizontal axis to oppose the direction of motion. Now what we want to do is, if you're in an AP class, this is going to be your free body diagram, and you're not going to add anything else. Then we would draw what's called a working free body diagram, any diagram that we wanted to add other things to it. So in this case, we're going to make this our working free body diagram, and we're going to break down the tension force into its vector components, its x component and y component. What does that mean? Well, you have a tension force that's acting up and to the right. The up part is going to be the y component. That's how much force is acting vertically of that tension force. And then you also have the horizontal component, and that is how much force of that tension force is going into supplying the force in the direction of motion. So let's go ahead and draw those. So I've drawn my components, fx and fy. Now, the fx and fy, we can substitute. We know we're going to use some trigonometry because we've enclosed a right triangle. So we enclosed a right triangle. So what we're going to do is we're going to show that fx and fy equals something, the hypotenuse times a trig function. So because the x component is the adjacent side, that's cosine. Because if the y component is the opposite side, that is sine. And we're going to multiply those trig functions by the hypotenuse. So we can see that the x component is ft cosine theta and the y component is ft sine theta. So now what we're going to do is we're going to write a second law equation to find the value of our acceleration. So again, we write our second law equation for the x direction because that's the direction of acceleration. And we can see that we have two forces now in the x direction. We've got the horizontal component of the tension, and we also have friction opposing that. So we're going to subtract those two things. Now, the standard way that I like to teach my students to do this is I always have the students add the direction of acceleration minus the opposite direction of acceleration, or the bigger vector in the x direction minus the smaller vector. And the reason for that is it gives us the value of an acceleration, and we can apply direction based on which way the net force is applied, positive or negative, up, down, things like that. So now we're ready to solve for the acceleration. So I've divided each side by mass, and now we're ready to plug our numbers in. I have 20 newtons times the cosine of 30 minus the friction force of 10 newtons divided by the mass of 5 kilograms. And I get an acceleration of 1.46 meters per second squared. So this is a couple quick examples of how to use Newton's second law. I hope this was helpful. If you found it helpful, please click the like button down below and don't forget to subscribe to my channel. Have a great day and an even better tomorrow.
If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter @CaviCoaches.